All right, today's lesson is normal distribution. Normal distribution is the PDF with bell-shaped curve. That's what we are looking at right now. And it's continuous distribution. Okay, so basically we're talking about something like heights of all, say, Australians, all of Australians. So we're putting all that in. It's going to be so much. And there will be a average height will be right in the middle, like highest point there, and the rest will just phase out. And because there's so many of us, it won't be suitable just looking at the column graphs or histogram. So it'll form the curve, and the curve will be look like a bell because you got the middle and then like average height, and then it will phase out. Okay, so that's just imagine that that's what's happening here. And therefore, important part here is that mean, mode, median is all the same. It's right in the middle because mean and median is the middle, and mode is the most commonly appeared scores. So that will be the maximum point, isn't it? Highest. So that stands out in the middle. Okay, there's examples here, such as IQ, birth weights, ages, reaction times, and exam results in a school, something like that. Now, we need to use a couple of symbols for this. So the population mean is mu, mu. It's the alphabetical letter for a Greek. And the standard deviation is a small sigma, but I'm just going to call it sigma. Okay, so remember that, guys. So let's have a look. Graphing a normal distribution. So obviously the mu is the mean. It's right in the middle. And when we phase it all out from the middle, you're adding and taking away the standard deviation. Okay, so just remember that. So I think the easiest way we can remember is the at the n bits, you're on the right is a positive, on the left is a negative. So you're adding 3 sigma, you're taking away 3 sigma. Example 11. A set of data is normally distributed with the mean 8.3. So our mu is 8.3 and standard deviation sigma is 1.2. Now you need to sketch the probability distribution function. So where is the mean? So I'm going to go with mean is a mu 8.3, and then sigma is 1.2. So I'm going to put 8.3 in here. So I'll go mu plus sigma is 9.5, and then I'm going to work it out like both sides at the same time. I think that's easier. 7.1. Okay, so that's my 9.5. That's my 7.1. Okay, and then I will go mu plus 2 sigma, which is 10.7. Put that in there. And mu take away 2 sigma is 5.9. So let's put all that in. So it's 10.7, 11.9, and that's 5.9 and 4.7. Okay, so that's what I've got there. Next one, a normal distribution has the probability density function below, so PDF here, find its mean and standard deviation. So it's the other way around, isn't it, really? So that middle part here is my mean, which is my mu, equals 15.6, And then I'm just going to look at this one. The next one is the mu plus sigma, isn't it? Which is 19. And we know that mu is 15.6. And then you do sigma equals 19. So sigma equals 3.4, because 19 take away is 15.6 equals 3.4. So therefore my mean is 15.6. My sigma, the standard deviation, is 3.4. Now, this is just the information. We don't have to have a nice, evenly spread it out, the bell-shaped curve. It can change, okay? Depends on the standard deviation, as you can see, because where they're all spread it out was like plus minus of standard deviation, wasn't it? So it all depends on that. All right, standard normal distribution. So we've done the normal distribution. Now we're doing a standard normal distribution. And this is something to do with the z-scores. I think you've probably heard about it. It is difficult to find the probabilities in the normal distribution by integration because the equation of the cumulative distribution function is complicated. Of course, it's going to be complicated because it's under the curve. So curve itself is very complicated equations. So to solve this, tables of probabilities, which in here is areas, okay guys, remember probability equals areas on this topic here, have been developed from the standard normal distribution. This is a normal curve that has been transformed so that the mean is 0 now. So mean is not any certain number anymore, it's 0. So basically, this is developed, created to make things small number valued, okay, easy to recognize. Because if you think about it, with the heights, like we have to deal with the 170, 189 point something, and it's quite big numbers. It's going up and a lot of details there. But if we want to get the information fast and easy, and 0 will be the best. Okay, so the middle is a 0. So think about it, some sort of like a directed number line. So the mean is 0 and the standard deviation is 1. Okay, so it's going up by 1 sort of thing, or down by 1. So that's basically what's happening here. Now, the values of a standard normal distribution are called z rather than x. So it has to have x has some other meanings, right? So we created this new system here, and we don't want to call it the same old name, so we come up with letter z. Okay, that's why it's called z-scores or standardized scores. All right, so let's have a look. Okay, so as we talked about, the mean, the middle, mu is 0 and standard deviation is 1. Of course, area under the curve is 1. It doesn't really matter. That one is whether it's a standard or not standard. That's the same thing. Okay, so let's have a look at the difference here. Normal distribution, we had mean, mode, median. I think about the three sisters of M. Okay, they're all the same in the middle. Okay, mean, mode, median, the same. And we use the X, and then we use the P, the probability of big X is less than or equal to little x. But standard normal distribution, the mean, the mu is now 0. Okay, it's not the same as mode and median. Standard deviation is the sigma is 1, and we're using z now. And also the probability, the expression of it is now we don't use big X anymore. We use a Z, is but less than or equal to the value A. Okay, so that's something is a little bit different. We are going to use tables. I would suggest you take your computer out and put another screen on it, second screen. Okay, so that we can have a look at the tables while we're doing the questions. So probability tables will be given. Now remember, the table values are areas because it's a probability. So let's have a look at this. So the table, I just take the sample out of it. This is not the whole table. Table is quite big, but I put a little bit of there. So if I want to find the area probability of when the z equals minus 3.43, for example, question 1. Okay, so if I want to find, say I want to find negative 3.43, so I want to have a look at negative 3.4 here, and my second, it says second decimal place, which is this. I will go here because that'll give me minus 3.43, isn't it? Okay, so that will give me minus 3.43 because these are all my second decimal place. And so my area for that value, z value, is at 0.0003. Okay, my probability that satisfies that z is less than equal to minus 3.43 is 0.0003. That's what that is. Okay, so that represents this part. Okay, this part. Let's have a look at the second one. It says z is less than equal to minus 3.04. So I'm going to go to here first. It's always down here, vertical first. We're looking at minus 3.0. So I'm on the minus 3.0, and then my second decimal place is 4. So I'm going to go to right to the end to the 4, and that is my area here. So the answer to this 3.04 equals 0.0012. Let's have a look at something different here. What's happening here? Now remember, the z need to be less than or equal to, right? It's the same as big X is less than or equal to little x. So it's still the same. But what if z is a bigger than equal to? So that means this area, not the beginning area on the left, it's on the right. Okay. Now I said if here because if I had to put minus 3.04, it's going to be right very small. So I just put it in the bit closer. And that's where minus 3.04 is. And we want to know this area, not the other one. So of course, we're going to use the complementary probability, which is 1 take away the whole area, the total sum of the under the curve. Area is 1 take away the other side, my left hand side area will give me the right hand side, wouldn't it? So I'm doing this 1 take away probability of z less than equal to minus 3.04 will give me the probability of z that is bigger or equal to minus 3.04. So that means 1 take away the previous value that we've found, 0.0012, that is 0.9988. Okay, so that's my answer. And what happens is in the between. So we want to find area in between minus 3.43 and minus 3.04. So basically what we're going to do is the whole area from the start to all the way up to minus 3.04 here, take away the area from the beginning to the up to minus 3.43 will give us the middle part, wouldn't it? So what I'm going to do is probability Z is less than equal to minus 3.04, take away probability Z is less than equal to minus 3.43 will give us the between. Okay, so I'm just gonna, no space, so that's the space. Okay, so let's have a look. So we got all the information from the previous questions we've done. So I'm just going to write it 0.0012 take away 0.0003. So that my answer, the middle area, middle part of the area is 0.0009. Okay, so that's my answer. So be careful about when the area is on the right hand side of the bell curve or in the middle of the bell curve. So there's two different ways of doing things. Okay, right. So these are the tables. Okay, the probability tables. So as we looked at the little section of it, so these are you always have to look at the vertical part of first, and then you look at the horizontal one, because this the horizontal one is your second decimal place. Okay, so this is a negative, so Z is a mean, isn't it? The middle. Okay, so this one is the below, it's the below the mean, this one, and of course that should be above the mean, wouldn't it? So the next table is all positive on the vertical line there. Okay. Question 12. For standard normal distribution, use the table to find. So it says to use a table, so you really need to look at the table now. If you could open the textbook, there are two tables that we need to use. There's 5 parts. The most of things we've briefly done it, so it's very similar. So part A, Z is less than equal to 0.6. So it's a less than, so it's just normal one. Okay, so the left hand side. Okay, so the value is 0.6, the less than. Now when you're looking at the table for that, you're looking at the table on a 0.6 vertically going down, and then horizontally you were looking at 0 here, isn't it? Okay, so it's a first column. Okay, because it's 0.60. So we're looking at 2 decimal places always. Okay, so if it was given 0.6, think of it as 0.60. And that is, if you look at the table, you'll get 0.7257. Okay, next one is already in this 2 decimal places. It's not too bad. So that's the up to where minus 1.83 on the bell curve on the left hand side of area, because that's the less than or equal to, and that will give you 0.0336. Part C. Okay, now we've got something different here, isn't it? It's not going to be much different. So it's going to be, we're going to just treat it as the same, really. So remember, less than or equal to, or bigger than or equal to, or just bigger or less, that's just same, because Z equals something is 0 anyway. It'll be 0.9904 from the table. Okay, now the next one, different, isn't it? It was supposed to be less than or equal to. So we're talking about right-hand side area. Okay, so if that's the case, it's quite simple. We have to use complementary probability here. So I'm just gonna write this. So 1 minus, if you look at the table for the z is less than equal to minus 2.7, you will get 0.0035. And then you take that away from 1, you will get 0.9965. Okay, so that's what we got. And if it's in the between, I told you, we're going to take away from the bigger area and take away the little area, we'll get the middle. Okay, so what I'm going to do here is equals, because I need more space. The bigger one is this, obviously, right? So z is less than equals 1.4. Take away is z is less than, because it's the left hand side area, so it's less than 0.3. So just remember, I think it's easier if you put that first as it is, but for this part you just put the z on the left here. Okay, so it's nice to have all the z on the left first. So don't just write minus 0.3 is less than equal to z. Just make a z is less than equal to minus 0.3. So it's exactly the same as this. We're just writing like in a 2 parts instead of 1 part. That's all. Now, and you have to find the individual values for each probability. If you look at the table, I'm assuming you are, 0.9192 take away 0.3821, 0.5371. Okay, so quartiles, deciles, and percentiles, we've done that the other day. So let's have a look now. For a standard normal distribution, use the table to find the median, the lower quartile, the upper quartile, the 84th percentile, and the 6th decile. Now, these are the areas. They're going to give you the area first, and you need to find the z value. That's what this is. So let's have a look at this. Median is 0.5, isn't it? Okay, 0.5. And lower quartile is 25%, so it's 0.25. Okay, and then let's have a look at the upper quartile. So lower quartile is 25%, but upper quartile is 75%. Remember? So it's a 25%, 25%. So up to here, so it's a 75%, so it's a 0.75. So I think it's a good idea to write the decimal first and then you work through it. So 84th percentile, so it's 84%, so basically 0.84. And 6th decile is a 60%, so it'd be 0.6. Okay, so that's the actual area was given to us. We just have to find the value. Now, median is easy. It's 0. So when you look at the table for 0.5 as your answer, the area, so 0.5 actually has 0. So median equals 0. Okay. Let's have a look at the lower quartile, which was 0.25, wasn't it? So 0.25, so that's a first 25%. Okay, so 0.25. Now, when you look at the table, okay, 0.25, you will get something in the Z scores with minus 0.67 is about 0.2514, and then when Z score is minus 0.68, you will get 0.2483. you might say, oh, there are other values missed, is that it's a 0.25 something something. 0.25 going to be in the middle. Okay, so you're going to pick the value that just below 0.25, just above 0.25. And then, these are two possible. We need to choose which one is a closer. Which one is a closer? I'm just going to just number this. 1 second. Okay, which one is closer to 0.25? The best one will be you're taking away from 0.25 and then find the less number, the smaller number will be the closer. But easier way you can think about is this is like plus like 0.014, right? And to make it to 25, what do you need? Like roughly about 17. Okay, you need about 17 needed, and you've done over 14 above. So basically what that means is we got 0.25 here, and then I have number that is 14 above is the 0.2514, and then down 17 I've got 0.2483. So which one is a closer? Obviously the first one, isn't it? So the 0.2514 is closer. So the answer is minus 0.67. Next one, upper quartile, which is 0.75. So I'm going to go 0.75. So I'm just going to pick the value that is just above 0.75, which is this, and just below 0.75, which is this one. Now, okay, so I'm looking at 17 above, and which one is 14 down, isn't it? Okay, so which one will be my best one? It's the 0.7486 is my pick, because that's the closer to 0.75. Okay, therefore my Z score, my Z value is 0.67. Okay, that's my answer. All right, next one. It's a 0.84, and I'm just looking at the table. So that's just below the 0.84, just above 0.84. Now this is about 13 above from the 0.84. That's 11 down from 0.84. So obviously this is better one. Now that will give me 0.99, my Z score. Sixth decile, so it's 0. It's a 60%, guys. It's a 60%, so it'll be 0.69, 0.06. So just above 0.6, just below 0.5987. Okay, so this one is down by 13. This is up by 26, obviously. Smaller is closer to 0.6. So my answer is 0.25. Next one, example 14. Okay, so this one is actually not finding anything much. It's shade. Well, that's what you thought, didn't you? But you have to find something, because when we shade and find area, you have to indicate the Z score, where the shading part will start. Okay, so we need to find the Z score and then shade. Okay, so let's have a look at that. Above the top 20% of data. So roughly, if I can just draw the bell curve. By the way, the bell curve never ends. Okay, so that goes forever negative, forever. but sometimes it looks like it's gonna finish, but it's not. So I'm just gonna go, that's my 0. Okay, and then you've got some other values here. And roughly 20% we're talking about, roughly working it out, I don't know, something like that. And this, if this is 20%, right, that has to be 80%, isn't it? Yeah, so that's my 80%. Okay, so we need to find the that Z score, okay, where it's gonna start. They're giving us that 20% of the area. So let's have a look at that. So to find the A value, that it's going to give us the starting score that gives 20% of the area. All right, so if I could find this is less than good. Okay, so that's what we can use table. Okay, this condition we can use table. Otherwise, we've got to use complementary probability. So I don't want to do that. So how about we find this left-hand side first and see how we go with that. We are looking at, again, looking at the area first. Okay, so just above 0.8, below, is that 0.5? Is it 5? So we're looking at the area where it's above, just above 0.8, just below 0.8, and obviously this is closer to 0.8. My graph or sketch will look like, now I need to put the A value 0.84, roughly 0.84 here, and then go straight down, and this is has to be 20%. Okay, so it's not my left hand side, it's my right hand side. Okay, so that's my 20% here. That would be the sketch. Okay, so that's all. Now remember, all this percentage and decimal converted to decimal, it's going to giving us area, not the value, area, and then we need to find the A, the value for our sketch. Okay, so above the top 10%, roughly here, that's my 10%, yeah? That's my 10%. So that's my 90%. What do I need 90%? Because the table is catering for the area on the left-hand side. Okay, so I'm going to use my left-hand side area. So that's what I've got. So the area we're looking at is 0.9. Okay, so that's my A we have to find. So I'm going to looking at the area just above 0.9 and below, just below 0.9. And that's 15 up, that's 3 down, isn't it? So obviously that's closer to 0.9, and my A, the value is 1.28. So my sketch bell curve is, that will be 1.28. And of course it's a top 10%, so it's on my right hand side. That's my 10%. So if I did this nicely, properly, I will have like this. Okay, so that's what we got, because that's the 10%. Okay, what happens if it was not above, if it was below? Then you don't really have to worry about finding the other percentage. You can just go with whatever you got. Okay, that's all for today's lesson. Well done, people.